Hello. Thanks, everyone. So this is actually a story about a failure and how I sort of wasted 4 months of my life. But it is a very interesting technical journey of how I wasted 4 months of my life. So hopefully it'll be enjoyable. If not, I do know a bit of Kubernetes, and maybe afterwards I can talk about that too. Okay, but that is already the wrong slide. Okay, so let me just go off the cuff and explain why I wanted to build a compiler for Google Slides. So before I quit my job to be an indie hacker, I worked at Stripe. So at Stripe, there were a few harrowing moments where you had to do huge presentations to executives, and we all had a corporate template. So there were 136 different variations of corporate templates and layouts you could choose from and put in your content. So it was grueling hours to pick like the right layout and put it into your slide and prepare everything. And so before the final rush, where you have to explain how your 3 months of effort resulted in a success, and that could lead to your promotion or like your next project being greenlit and stuff like that, it was very important to get the presentation right. And to spend like 6+ hours just picking the right layout and organizing stuff and reducing font sizes was ridiculous as an engineer when you were getting paid like hundreds of dollars an hour just to move text boxes around. So I couldn't imagine how anyone could tolerate that. And I thought that after I quit my job, maybe building an AI assistant to do all of that for me would be like the best idea ever. There are a few competitors out there that, like Gamma, beautiful AI, like could name 10 more. All of them only do slide generation. They don't do slide edits. And that's, as it turns out, it's really, really hard to make AI assistants to edit proper slides. And we will go into that more. But why a compiler? So to understand what a compiler does, just as a raise of hands, who here has taken compiler courses already? Okay, so no one. So we're going to go off very basic and go from zero knowledge to hopefully making compilers not sound like an intimidating term. So all a compiler is to take source code, which could be a string. Maybe if you use some more interesting languages, it could have like graphical nodes to drag around. But all of them essentially come down into a structure that you compile or transform into a set of instructions. So I have a very nice slide here that I saw on Twitter. I always like this kind of stuff. If you think that compiling is really could be anything to anything, turning hydrogen into helium technically is a compile. But luckily for us, this Google Slides thing, we're taking text. So it's input neutral and output neutral because we're turning it into Google Slides API instructions right here in the middle. So traditionally still a compiler, but if you ask actual people who write compilers for a living, they would say that what I built here is probably not a compiler, but I digress. So the whole idea is AIs nowadays are really good at writing code. In fact, they're amazing at writing HTML and CSS, so much so that it's made me think, what if I just converted the problem into code, into HTML and CSS? I mean, what's so different about a presentation? You put stuff on a canvas, maybe in 16:9, maybe it's 4:3. It doesn't even have like responsive layouts. It's an easier problem of writing a website. So that's what I started to do. And AI assistants, they are really not that complicated. So nowadays you see like Claude Code, Codex from OpenAI, and maybe MCode, which is more generic. They all just support a bunch of function calls. So function calls are really just a bunch of parameters that the AI can give to you, and you execute them outside of the code, outside of the program that the OpenAI or LLM model provider gives you. And yeah, so it really isn't that hard. In fact, as you can see here, OpenAI's codex only has 3 cores. All of it really comes down to their pricing model. So they are able to give all of this is because they are giving money away. So if you pay $20, you may be using up to $60 of usage. That's how they retain you. And yeah, that's probably one thing. Be careful not to get bought in too much to the hype. The prices aren't as cheap as it looks. Okay, so now we have our problem. Like building presentations are a huge waste of time, like reorganizing text. And we have natural language that could give us some really beautiful presentations. So all we have to do is to take HTML and CSS and transform it to Google Slides API. How hard could that be? Yep, and so this was what I thought I would be doing and what would be maybe 3 weeks of hacking at most. But it turned out to not be. So it sounds very simple on the surface, but the gap between this is where all the interesting stuff happens, and this is where we'll get more into how a compiler works. And interestingly, this is not the first time I've written a compiler. So if you guys have used NUSMods, on the module page, there is a prerequisite tree. So this has been rewritten by newer contributors, but I was the first author of the first one. So as you can read on the slides, if we take the prerequisite, it's like, if you're doing this, then you must have completed at least one of this, or this and this. And we transform that into a tree, so it's way easier for you to visualize. Yep, so in the past, this was all written by humans. I think it is still written by humans, and being humans, we all make mistakes. So that compiler had to be very, very forgiving of what the prerequisite text could look like. If you're interested, feel free to look up the code. It's open source. Really, it is quite simple. Probably doesn't even count as a compiler, maybe a parser at most. But I digress. All right, so for those who don't know what a parser is, it is primarily the first stage of a compiler, where you take the source text, meaning your source code, say JavaScript or C, and convert it into tokens. So tokens would be, say, if. So the letters, the ASCII characters IF would be considered as a token. Yeah, and sometimes this is also called tokenizing. The next task would be being the Lexer, but it's all mentioned in this very famous Dragon book, which is all about compilers. And 80% of it is about compilers. 80% of it is all about parsing. My mistake there. So that was back in, I believe, 60s, where parsing took a huge chunk of the time because, well, CPUs were so slow. But nowadays, parsing is easily like 0.2% of the entire time of a program. It is really, really not worth talking about it. And so I used something I've already used in NUSMods, which was HTML parser 2. So, why did I use this? Sorry, this was in a prior project before I contributed to NUSMods. This was parsing NTUs modules. That's right. Yep. But the thing is, just reuse a parser. Lots of them out there takes source text and turns them into tokens. Very easy. Then the next part is slightly less usual. Usually what you have after you have tokens is you change them into an AST, which is an abstract syntax tree, then you convert it into your actual instructions. So because HTML parser 2 already gives you somewhat of a JSON structure of the HTML and CSS, it's just like open. Actually, might have something to show you, right? Yep. So here's a visualizer of HTML parser 2. Yep. So as you can see here, we have a body, right? So it's under the HTML tag. We have a bunch of children, and the body has a bunch of children, and the body has text. Oh, zoom in, right. Or more simply, this is, yep. This is what we have when we parse HTML and get back a JSON structure. So now we have a JSON structure. What do? We go diff. And diffing means that we're taking structure from the left side and taking a prior JSON structure and comparing the two. So this is, again, another library called JSON diff patch. Why I use this is because it was suggested by LLM, and it looked reasonable. So I really thought this would take me like 2 weeks, right? So I hacked together everything. So that's why I did not go into very deep considerations of my libraries. But what it gives you is a JSON output. So here we can see that between these two structures, we have some insertions of population. We have some removals of English, and things like that. So given this difference between the two JSON structures, now we can finally do the interesting part, which is generating the commands. So I apologize if the code is way too small to be read here. But what we do is, okay, we take the two JSON structures. We already know what the difference is. So when we see an update, or meaning an insertion, we will generate the commands to insert that particular JSON structure. So if it's generating a new slide, we call upon the create slide command. If it removes a thing, then we call the delete text or delete element command, and so on and so forth, until we have matched every single thing. Then when we finally generate all of the commands, then we send it over to Google Slides API. And probably a good segue here to how Google Slides API works. Okay, so as you can see, there were only 3 methods in their presentation API, and the only way to update anything is to do batch commands. And every batch command, you have to do it imperatively as a command. So there is no such thing as say, okay, given this prior JSON output that you gave me from reading the presentation, I can post you a new entire slide presentation and you update it for me. There is no such API. In fact, you have to recreate all of that using all of these imperative commands. And that is why we had to essentially build a compiler, because there is no replacement API, so to speak. Yep. As you can see here, every single property that you want to update, it has to be turned into a JSON command. And all of this are pretty nasty to work with. For example, the update text. Okay, the update text style looks pretty easy to work with. Just take a text range, you just give it a new style, and looks like you're done, except a bunch of conditions here where it's like, okay, certain text styles may change, so okay, you have to make sure to take care of that. Range belonging to a list and a paragraphs bullet is also updated. That is probably where I wasted like a week plus into fixing this. So we shall take a look at that if we have time. Okay, so diving deeper into what goes wrong when we generate the commands. So Google API and Google Slides essentially operate on IDs. So these are unique strings belonging to, say, a text element, a bullet, a paragraph, and so on and so forth. And AI LLMs, they are not deterministic. They are wrong pretty often, and they love to invent fake object IDs. And that is where you have to correct for them. So say, for example, you have an existing slide called title 123, and it generates a new one. Your div will have the same ID, but if they suddenly change it to title 124, then you have to suddenly compare the structure. So basically an object hash of the content and compare it. So now you know, okay, the ID that it gave me was false. I have to fix it so I don't accidentally recreate or blow away changes. And the whole reason I'm doing this is because I only support a subset of the commands. I cannot fully regenerate an entire slide. So that is why. And the other thing is, if the LLMs love to, the whole principle of how an LLM works, it operates on the previous tokens being generated, right? So if a previous token was generated, it really loves to recreate it. So it loves to generate duplicate tokens. So now you have to detect collisions as well, right? And the hard part of our collisions is if you have a lot of tokens that come in, you could perhaps just keep track of the IDs you have already seen, but that issue is you will have a lot of token usage. So if you have a whole bunch of random tokens, those eat up a lot of additional tokens basically, and you have to pay more money. So the only way to save on money is to keep them deterministic. So basically count from 0, 1, 2, 3, so on when you see them. And I also decided to base 64 hash them. This is OpenAI's tokenizer. So as you can see from the top, the numbers, it takes 2 tokens. At the bottom, it takes 3 tokens for the larger numbers that are base 64. But I believe because I'm using Google's tokenizers, the ones at the bottom actually take fewer tokens than the ones at the top. So it's all a whole bunch of unique hacks, I guess, or workarounds, or ways to save money between different LLM providers based on their tokenizers. Okay, so we cannot, or rather we want to save our money, so we don't want to randomly generate IDs. So what we do is we have a 2-pass solution. So on the first pass, we go through all the HTML. We read all of the IDs. Then we build a registry. So now we know which ones are duplicates, which ones are hallucinations, and now we can generate new IDs on the second pass by keeping track of them. So yeah, that also took up a long time because rewriting your code to work from a one-pass solution to a two-pass solution is pretty tricky as well. Yep. So now the performance benefits would be, okay, you don't really have to do very complicated conflict resolution. If you want to look forward, that is, sorry, what I mean here is you could avoid a two-pass solution by writing a very complicated first-pass solution that reads forward until you see a duplicate token. But that is very tricky to do. In fact, if you're writing a production compiler, especially for more older languages, like C, for example, they'd love to have forward tokens, meaning that in order to disambiguate what a certain thing means, you have to keep reading forward, keep reading up to like 16 or 64 tokens to understand, okay, this is what the token is. This is an assignment and not a pointer. So go all the way backwards and read the next token and process that. That is very expensive. That's why more modern languages like Rust or Zig, you'll see all of their syntax do not require reading forward. Yep, it's more efficient. But, okay, so that's tokenization again. Yep. Okay, so here's where I run out of content. Well, yeah, because, well, I initially thought I had more time to prepare, but yeah, how? Okay, so this is where maybe like a demo would be useful. I would say that in truth, 80% of this, the AI helped me generate, but there were a whole bunch of things that it failed on. So that's where I'm still trying to improve and make this a production app. So part of it is that if you have a very complicated template, say if I was back at Stripe with my 136 pages, the amount of tokens it would use would be almost 1 million. So $1 million, depending on which model you use, could be 30 cents, could be $30, could be 350. So reducing the amount of token usage really does make it a lot cheaper. And the demo gods really blessed me with a non-working solution. Is that working? No? Okay, so an AI assistant that lives in Google Slides, this is what I was trying to do. So right now it's using Gemini 2.5 Pro. Okay. I'm being very boring with my prompts because as we can see, the demo gods do not like me. Okay, why is it? Network connection loss. Of course. Okay, in the meantime, does anyone have questions about LLMs, AI, NUSMods, anything really?
When are you going to sell this to Goldman Sachs or some IT firm?
Yeah. So surprisingly, the accounting firms, the big four, I believe like the biggest one already has their own slide generating AI. So that's already a no-go. Yeah. So I think my target audience supposedly would be business consultants. Yep. And yeah, so as you can see, previously we had a giant slide, right? And now it has changed the layout and added some more content. And it's still going for some reason. We shall see. But in effect, if you can think in the ideal hypothetical world that I spend another 4 months on this, it would potentially help you edit slides as just as easily as it is reading code. Part of it, right? Maybe this would be interesting to show as well. Who among here know about Tailwind CSS? Okay, a handful. So Tailwind CSS, as the name suggests, helps you write CSS with a very simplified syntax. So as you can see here, instead of declaring CSS, it uses shorter strings to write code, to write CSS. And this is very token efficient for LLMs as well. And this is why instead of using CSS in my bot, I'm actually using Tailwind CSS. And in effect, it is a smaller parser within where you read the class attribute, which all you get back is a string, right? Then you split it up by white space, then you take each one of these and convert it into a style attribute on Google Slides. Yeah. Okay. Cool. So maybe lastly, what I'll do differently with this. Honestly, I'm not too sure where to go now. I basically spent 4 months trying to make this work, and it keeps not working. There is endless edge cases, which if you guys are interested and aren't already hungry with the smell of pizza in the air, I can go on and on. There's stuff like how I handle like bullet nesting, paragraph markers, how I still have not done stuff like tables, like SVGs, diagrams, sheet, Google Sheet linkages, not the other word. Yeah, and many, many more stuff. So it is still not done. It is still pretty much an alpha demo. But if any one of you are desperate to generate slides and for some reason all of the existing competitors out there don't satisfy you, feel free to reach out to me. Yeah. And yeah, the other stuff would be probably find a different solution. So there's one tiny thread there where in the future, the function calls would be a lot more powerful. Right, I mentioned function call at the start. In fact, I probably missed and did not explain how the AI edits the content. All it does is I give it a function tool that says, okay, give me a string to replace and give me what you want to replace it with. That is all. That is one tool. That is all it has access to, and surprisingly, it does pretty well. The hard part is really just reading and fitting everything within the context window. Yep. But function calls right now, they do not go deeper than maybe like 2 layers of JSON. So I could theoretically just give it the entire JSON blob that I started with all the way at the start. Like here, right? Like if I had this, I could pass in the entire AST and say, okay, give me back your updated AST. And that is not possible because LLMs, they just fail after the third nested level. But who knows, maybe in 3 years, we will have that. And yeah, I guess that's pretty much it. The hard part of a compiler really is just generating the operations, the commands, the parsing, the tokenizers. They sound very abstract, but really they are conceptually very, very simple. And in fact, nowadays you already have tools at your disposal. You could grab them, install them, and go off from a deeper level. You don't really have to go that in depth. And cool. Thanks for listening to me. Yeah, any more questions? Great.
How much does one request cost with us?
Sorry.
How much does one request cost?
How much does one request cost?
Yeah.
So it really depends. Right now I'm using Gemini 2.5. I can show you the cost, right? So over here, the previous one was 1 cent USD. But previously I was using Gemini 2.5 Flash, which is, I think, like 20x cheaper. So over here, it's, I don't know if you can see it, it's like 0.2 cents? Yeah. So it is quite cheap, but like I talked about context management, right? Some of this could get really huge with token usage. And this was with Gemini 2.5, right? You saw previously it was like 0.2 cents. Now it's 8 cents. So that's 40x, right? So if I take that and put it into 2.5 Pro, and 2.5 Pro also likes to generate more tokens, so you could easily like 80x that cost. Yeah, pretty expensive. Pretty much that's all how the AI and coding tools operate nowadays. If you use like Cursor, for example, you pay $20 USD, right? They give you like 60, 80 USD worth of tokens for now. In the future, when they need to actually make money and not burn it, it's going to be a lot more expensive. And reasonably, from what I've learned from AI researchers, like people who are actually building and training all these models, they are not foreseeing the token cost to actually go down, because all the frontiers, right, as they get better, you won't want to downgrade. Like, it's not like you're driving 40 miles on a road and now you have a car that can go 80. You'll be like, okay, never mind, I'll just stay on my 40 miles per hour because it's cheaper. Like, yeah, everyone would just guzzle more gas and go faster.
So, just now when you prompted it to include bullet points, right? And then it automatically did like layout constraints, right? Is there like a specific prompt that you use to do it, or does it just automatically know how to layout position?
Yeah, so I talked about how it converts the Google API JSON format into HTML. So behind the scenes, Google Slides actually has themes and layouts. So you can see that these are all the possible layouts that you can pick from. This one is like the most basic, right? And it already has 16. And the whole reason why I use this template is because it is the most token efficient. I really wanted to give this like a nice look. What was that? A template, right? Like Google Slides has like this really cool themes that you can go with. Like if I just like use this, okay. And if you check out the number of layouts we have, it's a lot more. And all this blows up the context. So it goes up to like 200,000 tokens or something. And that gets expensive for us. And even worse is the LLM just cannot handle this. Yeah, it just gives up. Yeah. So in short, the layout is converted into HTML, then do some finesse where the LLM knows how to pinpoint to which layout to use. Then I generate the commands to generate the slide with the layout, and that's how you get a slide with bullet points. So context management is a very complex issue. So if you use ChatGPT.com, right, you only get 32K tokens of context, and what they do is they basically compress it, sort of summarization, so it can continue on to the next chat. But there's no way we can compress any of this, right? Every single layout component is essential here. So I really have to be creative. So one thing I'm thinking about is whether I can give it just a summarization of the layouts it can pick, then only review the layout information when it picks the right layout. But it gets a lot more complex. The more tools you give to an LLM, the more it hallucinates, and the less it will likely to pick the right action to do. So you have like this like juggling and balancing where it's sort of like voodoo magic. Or if you guys have played like Warhammer 40K, I believe it's like Tech Priest, where it's like all of them are just praying to the tech god to pray that, okay, give me something that works. Yeah, and that's how I feel like what I'm doing now 50% of the time. It's just praying that, oh, please let this prompt work. Yeah. The evals don't really help. Yeah. Cool. Right. Very interesting questions. Thanks for taking interest.